And we'll take the another example, that is 8 queens problem. So in 8 queens problem, what is the heuristic function? What is the heuristic function of 8 queens problem? That is the number of queens attacking each other directly or indirectly is the heuristic function, isn't it? So successors are all possible states moving one queen in the same column or in the same row or diagonally. So total possible successors will be 8 into 7, 57. How it is 57? There are in a chessboard, there are 8 rows and 8 columns, and for each queen, how many boxes it can move? 1, 2, 3, 4, 5, 6, 7. So 7 moves it can move either in a column wise or row wise or diagonally. There are 8 such queens. So one queen can move 8 positions. There are 8 queens. So 8 into 7, 56 possible successors are there. Now what is H in this case? What is H? Heuristic value. What is heuristic function? Number of pairs of queens which are attacking each other. What is H here? How many queens are attacking? How many pairs of queens are attacking each other? This is the only pair which is attacking each other, that is H is equal to 1. Like that, if I give you the chessboard with the queens in different positions, you should tell me what is the H value. So in this example, can you tell me what is the H value? That is how many pairs of queens are attacking each other directly or indirectly. What is the meaning of directly or indirectly? See, in this example, H is equal to number of pairs, number of queen pairs which are attacking each other, right? See, this queen is attacking this queen directly, and this queen is attacking this queen directly. But this queen is attacking this queen indirectly. In between it has one more queen, but still they are on the same diagonal. Those two, that pair is also attacking each other. Like this, if you count, how many pairs of queens are attacking each other? Can you tell me? Count. So directly, indirectly, if you take 17 pairs, because directly, indirectly you are taking 17 pairs of queens are attacking each other. What are those numbers which are in each box represents? That is, if you place queens in those places, how many? What is the H value? Now, say suppose I will move this queen here. If I move this queen here, how many how many queen pairs are attacking each other? 15, because the number is written there. So now if you move this queen here, only the 12, H becomes 12. So this combination gives you what is the H value for this combination and what are the possible successors. What is the H value in this state and what are the possible successors? You work on it and tell me. And these are some more examples. And this is another problem. See, for a supermarket with many checkout counters. You see, when you go to supermarket, there will be many checkout counters, okay? So which counter you select? Even in a metro. To get into the metro, there will be so many queues. Which queue you will select? Based on number of users, a number of people in that queue, right? In a number of, when we consider this metro queue, you will consider only the number of people. But when you take the supermarket checkout counters, what are the things you need to consider? The number of users or the number of customers in a queue, and what is their cart size? How many objects they have in their cart, and also the speed of the cashier, and with what speed the cashier is processing each customer. Also, all the three things matters to select a queue, right? So, what is the heuristic function here? In this case, heuristic function is to minimize the total predicted waiting time. So based on these three criteria, you will select which gives you minimum waiting time. Right. So there are possible approaches based on the workload based heuristic, or predicted time time to clear, or shortest queue with capacity constraints, min-max difference heuristic. But we generally select workload based heuristic. So how do you implement this? Using these three factors, that is customer behavior, service rate and queue length. So GFN will be is the time taken to reach the checkout, and HFN is the estimated time for a cashier to complete the process. So this is another example for hill climbing. So suppose this is start state and this is a goal state. So goal state is how to keep these boxes, the position or the proper position of keeping these boxes. That is, A should appear first, and B should B should be placed on A, C should be placed on B, and D should be placed on C. Okay, and what is the local heuristic here? +1 you can give for each block which is placed on a right position, -1 if it is placed on the wrong position. So goal state will always be correct position. So +1 +1 +1, it is total is 4. You take the start state from where we are taking the initial state. So if we take that, whether is B in its right position? No, it is in wrong position. So -1. C on B, it is right position, +1. D on C, it is on right position compared to goal state. So it is +1. And A is on wrong position, so -1. The total value will be 0. Now, how do you make it correct? How to reach the goal state from this state? So start from here. You take A on down. You know, do you remember we used to play a game like this? So now A is placed, taken to ground. So now A should be the first box. Now it is in the right place. It is +1. Right. So now the value is 2. Like that, if you take D on A, if you take D on A, it is -1 +1 this side, because B is on wrong position and C is in right position, -1 +1. And if you consider this, A is in right position and D is in wrong position. So +1 -1, it gives you 0. So now if you move further like this, -1 B and +1 C is in wrong position. So here +1 +1. So like this, you have to take it down and keep it onto the right position to reach the final state. This is another example. Thank you.